Hello and welcome to today's video. So on the workbench today we have an NLG511 battery charger. This one happens to be serial number 302. It's in for repair / evaluation. Customer is having a CAN transmit failure error message, and so I got this one all hooked up and it looks like it works fine. So we'll go ahead and show that. I did build up some cable sets here. I've got these are all 33 kilo ohm resistors bypassing all three temperature probes. You notice one of them is soldered on there because I had a 1.1K resistor across there, because the datasheet for this charger says that that should be a PT1000 temperature sensor, which puts out 1.1 kilo ohms at room temperature. And it turns out that all three of them are actually just regular NTC 33 kilo ohm at room temperature sensors. So I swapped that out. Now it's happy. I was getting the temperature 1 failure, but I fixed that. Not related to the CAN problem that it was having. So I've got serial going off over to the ChargeStar program so we could set it up in CAN mode, and I've got the other cable going over here to my CAN bus adapter. This has got the termination resistor in here, 120 ohms, and a couple jumpers. I can pop that in and out. It's just for going between a standard CAN connection to the Cavasar CAN connector. And there's a couple pins on there so I can hook up the scope to probe it if I needed to. I also got the enable switch here plugged into mains power, running off 120 volts AC. And then coming down here, we've got the load on the battery pack over there, and battery, or the voltmeters on there, so we're down to 152 volts ish. It's kind of sketchy, but there's some separation there. It's not going to short out, hopefully. Hopefully we'll see the lights get brighter. Over on the CAN side, they're kind enough for the NLG5 to give us the CAN specs. So this is the entire CAN listing, and so I've filled out all of the receive section here that I have to transmit to it, and I can show you over here. I am commanding, this is what I'm sending. So the 80 hex is telling it to enable the charger, and then the 032 is commanding, that's 50, which it's 0.1, so that's actually asking for 5 amps is the maximum current I can draw from the mains. The next 2 bytes here is 6D6 is 1,750, but again it's also times 10, so in reality I'm asking for 175 volts DC, and then 32.0 again is 50 in decimal, and that's asking for 5 amps. So essentially I'm telling it I want 175 volts, 5 amps max, and that's what we're going to dump in the battery pack. You can see we're not getting any errors. We got 0 in the error. 614 is the errors, and we have zeros across the board, so that's working fine. This is the packet that I'm sending, that 80 032 06 D6 0032. We're sending that at a pretty decent rate. I don't actually know what the rate it is that I'm sending. I could probably calculate it, but it is literally my camera sitting on the enter button. So that's determining our transmit rate. I'll show you that if I take the camera off, it kicks out and it'll throw up a bunch of error message about CAN message timeout. But everything else is just, these are all the temperature sensors. So if you were to do the math on this power stages, these FFFF ones here are actually the temperature sensors. That's 25 in 25 degrees Celsius, because that's what I set all the sensors to. This is the power stage. You can kind of see it's cooling off. I had it on earlier. So I know that's working. So we'll go ahead and flip the enable light, or enable line, and I'll see if I can get this on here. You should see the voltage and the bulbs get a little bit brighter in 3, 2, 1, now. So maybe it came across, the bulbs got brighter, but you can definitely see the voltage is starting to climb up. Targeting 175 volts, and we're limited to 5 amps, so we're trying to run all these lights and charge the battery simultaneously, and eventually it'll hit 175 volts. But if we come over here and look, we've got no error message, and we're charging. And yeah, so it looks like everything's working. We come over here, you can still see zeros across the board. We've got no error messages, everything's happy. And so I don't know if it'll get to 175 volts because I think, oh, maybe it will. We're going to get pretty close. Maybe. But here, I'll show you what it happens if I were to, I'll pull the camera off. You ready? And if we go over here, you can see now we got all kinds of error messages. There's a fault, and that we've overran our minimum number of CAN messages, and you can see the voltage is dropping back down because we're now draining the battery pack through the lamps. So we're counting down 156 volts, dropping. And if we come over to here, we got an error message on the charger now. So it looks like everything's working. Yeah, it doesn't look like the problem is with the battery charger itself. Looks like this works perfectly fine. So I'm guessing it's probably going to be a problem with the battery management system that's in the boat is not sending the correct packets over to the battery charger that it's expecting. And or there's just a wiring problem, like CAN bus is screwed up somehow. CAN bus will actually work if one line is down, is missing, but it can get pretty flaky. So it's possible that you have an open circuit. So I would definitely try ohming out from the battery charger, like unplug this, ohm out from there over to the BMS board, and anything else that's on the CAN bus. Make sure that you have a good connection between both sides of the CAN bus, CAN high and CAN low lines. But anyways, looks like the battery charger's working perfectly fine. Anyways, thanks for watching. Bye.